Hey folks, Don Eichhorn here. Hey, I forgot completely that I was going to video record the project that I'm working on. I'm actually building a pump for pumping approximately half a gallon of water per stroke from my well on the property here so that I can fill larger tanks to feed a gravity system. So a pitcher pump is great and wonderful. Yay! But it would take way too long and way too many pumps to fill up the tanks that I'm going to have. So I can't find one to purchase one, so I'm building a pump to pump larger quantities of water. So I forgot to include you when I was getting started, but fortunately I'm not too far along. So let's see, I'll probably have to reverse this around so I can show you what I've got going here. So let me stop here. We'll call this video 1 introduction. This is just September 2016, building a water pump to extract large quantities from a well. All right, so look at video 2 and I'll catch you up to where I am. Thanks. Okay, here we go. Let me get you caught up to where I am. Basically, everybody's probably familiar with this kind of little air pump. You use it to blow up an air mattress or floats or something like that. And basically all it is a pump. You have little holes in the bottom. When you extend the rod, it sucks air into the chamber up here. When you push the chamber down, it forces the air out of the hose and hopefully putting the air in where you want the air to go. Now, what I'm building is basically similar to this, except it's for water. And I can't just suck it in from around it because it's not like I'm emptying a hole. So it has to have an inlet pipe and then an outlet. And this is done through check valves. The check valve is simply a valve that will only let the water flow one way. So this is kind of a key element to the process here. Water will go one direction, it will not come back the other. That's a check valve. So anyway, where I am so far is I'm building what I would call the cylinder, actually, or the piston. All this is made of is 2 3-inch Schedule 40 PVC caps. Now what is bolted on the top here is a simple flange, a 1/2-inch flange, so that I could thread my 1/2-inch galvanized pipe into that to give me a rod to operate the piston. So it looks exactly like this. There's a simple flange that's bolted by 4 bolts through the cap, and then I can thread my 1/2-inch rod into it. So it's hollow, it's just glued together, heavy duty PVC cement. I don't want this coming apart. It's sanded down a little bit, but basically that's all there is to it. Now, what the main function of this is the absolute core of the pump. This piston will fit perfectly inside of my 4-inch PVC pipe. Okay, so this is not anything, nothing's cut to size here yet, I'm just catching you up. To make this operate, it has to run straight up and down in this cylinder in order to create the vacuum to draw the water into this area. So that's why I have this flange set up inside this 4-inch cap so that this 3/4 inch flange, I don't know if it'll fit through there with the cap on it. Let me just take the cap off. Okay, so basically that's a 3/4 inch flange that the 1/2-inch pipe fits through without threading into it. And then the 4-inch cap just fits on top of the 4-inch pipe. So inside we have a piston with a rod, and you can already hear and feel the air being forced in and out of the little surrounding hole here. So I think when it comes time to move water, it's going to work pretty easily. So far that's where I am. Let me pop this off of here. All right, so you can see, very simple, just 2 caps put together, one on top of the other, with the flange to thread it in, fits in there perfectly. So with that done, next thing I'm going to do is start putting the pieces together for the bottom of this, if I don't break all my stuff. And so I can start creating the system for the check valves so that I can have water coming in one side, getting sucked up into this tube, and then forcing that same water out, coming out of the other side to go into the tanks where I want it. So I'm going to put a little bit of that together. Now the one thing, I want to be able to take this apart in case I ever have to get to the piston inside. So I need to put a threaded fitting on the bottom of the chamber here. So I'm going to glue this up, and then once that's on, then I will be putting the other threaded connection on, and then I'll actually build the other pieces to that, just so I'm able to disassemble and get to the inner parts. So anyway, that's what's going to happen next. So once I get that done, I will show it to you and show you what's next. All right, sorry for the erratic camera use, but working with one hand makes it a little awkward. All right, bye. Okay, now for this piece, I actually told you wrong a few seconds ago in the other video. This piece does not go directly onto the 4-inch pipe because the piston will not actually fit through this fitting. That would not work. But it does fit through the female version. So it had to go. It had to go with the coupling onto the 4-inch pipe, and then the female threaded fitting, which then just receives the male threaded fitting. So I put that on, so the piston will actually pass through here and be fine. The only other thing that I did so far was on the bottom of this threaded fitting is I put a reducer in the 4-inch down to 2-inch because I'm going to be using a 2-inch cross to feed into my cylinder. So this side will be water coming in, actually to go this way, but it'll be coming in and getting sucked up into the cylinder. Check valve will be over here so the water can't be pushed back that way. Then when the piston comes down, it'll push the water out this way and drive it to where I want it to go. And then this down here, the reason I wanted to cross was just to be able to build a stabilizing plate to be able to mount this thing to the floor. So basically in the next step, I'll be attaching the cross to the reducer that goes onto the bottom of the cylinder. So, all right, so that'll be the next thing. Well, that one didn't take very long. So basically what I did, let's see, where did I leave off? I got the cross connected to the reducer for the bottom of the cylinder. So that's just a little piece of pipe that makes that connection. So the cross is in. Then I went ahead and put the foot on. Basically, the foot plate is just a toilet flange used upside down. And so I had to go from the 2-inch pipe back up to a 3-inch pipe to fit into the toilet flange. So with that all together, you can see we got a little bit of a more stable unit that I will be able to bring my pipes in and out, and once this is connected to the floor, it'll be even more stable. But with that done, this will just thread onto here. Let me slip that on there real quickly, a little bit. And so it's starting to take shape. You can see where it mounts to the floor, pipes coming in and out. Check valve will go on each side so that, again, it can come in this way, but it can't go back. Then it can be pushed out this way, but it won't be able to come back this way. So the whole up and down action of the piston will suck it in and push it out, and it can only go the way that I want it to go when that time comes. So we are getting there. Now, to move a half a gallon of water per stroke, what I need is approximately 9 inches of movement of this size piston. So I may actually make a little bit of room to have it be able to do a little bit more than that, because there could be a little bit of loss when I get into the mechanics of the handle. So we'll see how that goes, but I may just make it a little bit bigger so that it's able to do a little bit more to make sure that I get my half gallon that I'm looking for. When it comes time for the handle and all that, I think I'm going to use a wheelbarrow handle, actually. It's a 5-foot long wood handle to make it very easy to pump that much water in one stroke. So anyway, that'll be down the road a little bit. The next thing I'll be doing is actually putting the pieces in. I want to have a threaded connection on each side of the check valves, because if a check valve goes bad, I don't want to have to throw away the whole thing. So since that's the only mechanical or moving part, I'm going to have a threaded fitting coming out of here, then the check valve, and then another threaded fitting so that I'm able to remove those if it's ever necessary. So that will be some of the next stuff that we will do in the construction of this pump. All right, thanks. Okay, let me catch you up to what I've done since the last installment. First of all, I finished off the cylinder. I wanted to get it cut to length and get the cap on, so I got that 21 inches for the overall piece, and then got the cap glued on, piston installed. So this part is ready to go, ready to be screwed onto the base. And so here, like I was talking about, all I really had to do was put a reducer in to bring it down from 2 inches to 1.25 inches. Little piece of pipe in there making a connection into the adapter fitting to bring it to threads. So then on here, this will simply get the threaded fitting, the female onto the male. Another little piece of pipe will tie that onto the check valve for this side. So when that's all said and done, it'll look just like this, except the valve will be in the opposite direction. This valve is set up for the flow this way, so this is the check valve, the pipe that exits the pump. So this one has to be put on in the same direction so it can only allow water to come into the pump, as I keep talking about, but it will not go back. Now, one thing that I did miss in my planning when I was buying all the parts is with the cross. Works out great, nice foundation, nice base, but I kind of need to plug this little hole down here. If I don't put a plug in the bottom, the pump isn't going to work at all. So little oversight there, so I'll either have to find or go buy a plug for the bottom base. But other than that, we're coming along very well. So I'm going to go ahead and glue these things up that I wanted you to see before I did. And once that's done, and once I get a plug, put in the bottom, I'm ready to test it at this point. Now, one thing I didn't mention earlier, if necessary, I'm going to see how it works just the way it is. But if you remember how the piston looks, just the two caps, if that doesn't give me a tight enough seal inside to create the vacuum that I need, what I can do is on that piston is use the table saw and just cut grooves around the outside of the piston. And I'll do that twice. And then I can get O-rings, which is just a round rubber gasket, and put it in that groove. And then I'll slip that in here, and that will seal the space between the wall of the cylinder and the outside of the piston, giving me an absolute airtight, actually, seal. So that will give me the vacuum that I need for sure. I'm hoping I don't even have to do that. I'm hoping it'll be tight enough the way it is. It's certainly moving the air the way it is. So we'll see. I'm going to try it like this, but I can always unscrew it and get back to the piston and add that if necessary. So at this point, I'm going to go ahead and finish putting all of this together, and I'll give you a shot showing you what that looks like at that point, and then I'm going to try to figure out a way that I can test it to see how much pressure I'm actually generating, and we'll go from there. Well, here we are with all of this part assembled now. I got the other check valve put on, and I got the other threaded fittings put on here, so I can tie into the other side of the check valve. With either, I did it this way with the the female portion attached to the check valve. So if I have steel pipe coming in, I can just thread it right into here. Or I have this if I want to use the PVC pipe that'll just glue into this. So that's the reason I set it up that way. And so I have the cylinder installed. And so it'll be ready to be tested out here as soon as I get a plug for that bottom, like I was talking about. So I have a lot of air coming out of here, so I'm hoping that won't be a problem with the water being so much thicker than air. I'm hoping that without putting the O-rings on it to seal it off on the bottom, that it'll still create enough vacuum and push to do what I want. But if not, I'll take it apart and put the O-rings in, and we'll be good. So, all right, so the next thing will be getting the plug in the bottom and then testing it out. So, to be continued. Okay, so here's the final installment for this piece. Now, all that I've done since the last piece was I built a little temporary handle for the piston. So that's just a temporary fix. And like I was talking about, I did get a plug to the bottom. So, all right, don't have a line to hook this up to, so we're going to have to kind of modify the test just to see if it'll actually work. Now, I'm going to have to prime it first, so I'll have to suck it up so that I can get this part filled with water before it'll actually work the way it's supposed to. So let's just see what happens here. Well, it's working. Not quite the capacity of money. So I will probably have to add the O-rings to the piston like I was talking about earlier. Yeah, it works, but not enough. It's just not fully. I'm not getting the pressure that I was before. Okay. It worked better before when I tested it without the camera. So I think it's just a little, putting it in there sideways. So, alright, I'm satisfied. Thank you.